Okay, here's another problem. This one features a solenoid, okay, so you can probably guess it's going to involve a magnetic field. Let's see, a solenoid is 9 centimeters long with a radius of 1.3 centimeters and has wire wrapped 350 times, okay? So if we sketch in our solenoid, so here is our solenoid, okay, this is 9 centimeters and the radius, okay, of our tube here, that's our 1.3 centimeters. It has wire wrapped 350 times, so in other words, it goes around 350 times from one end to the other. And we want to know how much current is necessary to produce a field of 2.5 milliteslas, and also how much wire is needed if we wanted to make this thing. Okay, so let's start with the current. Okay, and we're given what the field is that we want. All right, and the way those things are related is that for a solenoid, there's a formula for this. The magnetic field due to a solenoid can be written as mu 0 times n times I. Okay, where mu 0 is that permeativity or permeability constant that we've got. I is the current, and we got to be careful here. This n here is not the number. Notice when we've got a small n like this. Okay, this is not the total number of turns. This is not our 350. Small n in these things is the number of turns per length. Okay, so in other words, n is equal to the total number of turns, which we usually call capital N in these magnetic things, divided by the length of my solenoid, which is 350, 350 divided by 0.09 meters. And so small n then is about 3,890, okay, turns per meter. Turns aren't really a unit, so I'll just write that as inverse meters. Okay? So that's what n is. All right? And so now we're all set to put stuff in here. B is 0.02 0.0025 teslas, okay, in other words, 2.5 milliteslas. That is 4 pi times 10 to the minus 7th Tesla meters per ampere. N is 3,890 inverse meters times I. Okay. And when we solve this for I, we end up with 0.512 amperes. All right. So that's how much current is necessary. The other thing we want to figure out then is how much wire is needed. Okay, and the idea then is that we have to figure out how much wire it takes to go around in this circle 350 times. Okay, and so if we can figure out how much wire it takes to go around the circle once, okay, then we just multiply that by 350 to get the total amount. Now the distance around once is the circumference of our coil. Okay. And you learned in some math class in your distant past that the circumference of a circle is equal to 2 pi times its radius, which is 2 pi times 0.013 meters, which works out to 0.0817 meters. Okay, so that's how much wire it takes to go around once, and so to go around 350 times, that's going to be 0.0817 meters times 350 is equal to 28.6 meters. Okay, so that's how much wire it takes to make this solenoid. Actually, a little bit more, because besides going around and around, we're also going up, okay? But really, it's just a little bit more than that is all. All right? Okay.